Okay, in the previous video, I showed how the Egyptian people uh, could calculate the kind of for the leftover when they take the division. And as you can see there, the combination of those unit fractions are many, right? And all different types of it. So whenever they need those calculations, it really took a long time, right? We can imagine that, right? And it turns out that they actually use kind of reference tables. So they already pre-calculate kind of possible fraction forms. And how can you convert that fraction into the sum of unit fractions? Once again, the unit fraction means the numerator is 1. Okay? And of course, they accept 2/3 because it happens a lot. They need that 2/3 a lot. So they have the symbols for 2/3. But other than that, they actually matching the symbols, actually assign the symbols for unit fractions only. And whenever they need any number between 0 and 1, and that is a fraction, then it can be written by the sum of those unit fractions, okay, some of them. And they didn't want to calculate every time, right, whenever they see that. So they have kind of cheating paper, right? And that's the collection of all the reference tables about what fraction compared to the sum of which unit fractions like that, right? And one of the kind of famous kind of forms of it is 2 over 3k style fraction. Then we can decompose this one into the sum of these two unit fractions. They already have it, right? But okay, then let's just check whether it's really true or not. Okay, so let's assume k is just any uh, kind of positive integer, right? 1, 2, 3, 4, anything like that. Then let's see how this 2 over 3k can be converted to the sum of these two unit fractions. Okay? So let's start from the right hand side. 1 over 2k plus 1 over 6k. Then we want to get this common denominator for the calculation. So let's multiply 3, the numerator and the denominator of the first fraction form, which makes 6k for the common denominator of these two fraction forms. So when you add them, we have 4 over 6k. Then let's divide numerator denominator by 2. Then it's 2 over 3k. So that's the proof of that, right? Maybe you can get that. So we just could check. So after have, so this is kind of formula for them, right? How to write down 2 over 3k, right? So let's say, how about 2 over 87? Then instead of really going through those kind of procedures, right? Write down those numbers, right? So you can imagine like 187 and 1/2 and half of it, right? It really takes long, but instead of, because of this table and the formulas we can get from the table, they could calculate right away. So 2 over 87 is 2 over 3 times 29. So the only thing they need to check is if the numerator is 2, then they just check whether the denominator is multiple of 3 or not, right? So 87 is 3 times 29, which means it follows exact that same format, 2 over 3k. Then by the formula, we can treat k equals 29, right? So 2 over 3k. Okay, then by the formula, it must be decomposed to 1 over 2k, which is 29, plus 1 over 6k. So 6 times 29. So it must be same as 1 over 58 plus 1 over 174. Okay, then let's just take care of such formula one more time. Okay, so that's for another case. So this is another next famous one. For any 2 over any integer, actually positive integer of course, and it should be greater than 2, right? So 2 over n can be decomposed to certain number. Okay? So in this case, it decomposed to like this. And the reason is we have a formula for that. Okay? So let's just prove that formula once again. Let's start from the right hand side. 1 over 2n plus 1 over 3n plus 1 over 6n. Once again, we want to make the common denominator. So the first term we need to multiply 6 and numerator denominator. And for the second term, we multiply 3 on both. And for third term, we multiply 2. And the last one is just 6n. Then all these denominators become 6n, right? So we have common denominator, so all we need is just adding all numerator together over 6n. And when you're adding 6, 3, 2, 1 is 12, right? So 12 over 6n is same as 2 over n after divided by 6, numerator and denominator. And that's the proof of that is equal to 2 over n. So because of this, for example, 2 over 101. So in this case, all we need is whether the numerator is 2 or not, right? Because that can be any number, right? Greater than 2. So it's satisfying in that format, 2 over n. Then the result is 1 over n, okay? And 1 over 2 times n plus 1 over 3 times n plus 1 over 6 times n. Okay? So that's how we got that form. Okay? So when you compare this one with the previous case, like a 2 over like a 3 case style, right? Then when you compare this one and that, this one is just 2 over n, then the difference is whether that denominator is multiple of 3 or not, right? So at this time is 101, so it's not multiple of 3, so we follow this method, right? So good. One possible really interesting question is, okay, even for that case, can it be decomposed to this way or not, right? So without using the previous formula, how about this formula, right? Please check by yourself, but the hint is, yeah, it's because we didn't give any information here, right? So it should work. Only the problem is it gives us more complicated forms, right? Because it requires 4 terms. The previous one only requires 2 terms, right? So, but please check by yourself. So let's see. Let's apply that formula here. Given number is 2 over 79. The first thing we want to check is whether 79 is 3 times certain integer, right? But that is not multiple of 3, so it's not. So the meaning is we can apply the first formula. Then let's just use second formula. Like let's treat this one is 2 over n, right? So let's say n is 79. Then by that, 2 over 79 equals 1 over n and 1 over 2 times n and 1 over 3 times n and 1 over 6 times n, right? Then after that, it's just simple calculation for us because we know how to do that, but for Egyptian people, still it's kind of big calculation, right? But that's another reason why they want to make that kind of table, right? Reference table. So they don't need to do that. So it's kind of calculator for them, right? Having those table is calculator for them. They just look at it and use those results directly.